Hey everyone, welcome back. Today we're going to continue working on algebra, and again, you can be particular and say this is abstract algebra, and we're going to look at these two quadratic equations, and of course we're going to solve for x for each quadratic equation. But now instead of, again, like high school algebra, that we're going to work on or work over the real numbers or maybe extend to the complex plane, we're now going to work over some particular rings. So in this case, we have z6 joins x, meaning that we have the polynomials with coefficients that are elements of z6, and again, that's just saying that the coefficients will be the remainder parts of any integers after divide by 6, and then we also have z12 join x. And again, it will be a little bit similar to the video that we did with some prime numbers, but as you can see, this time we no longer have prime numbers. And in abstract algebra, we will call the ones that with prime numbers a finite field, because we can actually prove that it is a field. And what does that mean by a field? It means that for any non-zero elements, you can always find inverse or multiplicative inverse, meaning that you can try to actually divide by any non-zero elements. So you can also think it as when you try to have a division, it is always allowed as long as it is not divided by 0. But now we no longer have a field, so when we try to do division, we need to be very careful now. And again, that is based on the property of not field rings, that some elements might not have multiplicative inverse anymore. Or you can also think that the what's so-called inverse is not unique. You will not only getting one answer out. Sometimes you might actually get no answer, and sometimes you might actually end up with 2 or more answers. So if you want to try yourself first, you can pause the video and I'll explain it after you're ready. Ready? Here we go. So we can still actually use the quadratic formulas that we know of to help us solving the equations. But again, since they're not field anymore, again, the numbers are not prime numbers, we need to be very careful when we do divisions. Here we go. So according to the quadratic formula, we see that here our leading coefficients, we can just try to write it out. A is just equal to 1. B will be -1, where C is of course equal to 0. So in this case, we actually, if we try to use the quadratic formula, we actually will get the following. We have -b, so it turns into +1, plus or minus the square root of b squared, which is -1 squared, which gives us 1, minus 4ac. And 4 times a, which is 1, is giving us 4, times c, which is 0, so we end up with 0. Then it will be all divided by 2a, and again a is 1, so we'll just divide by 2. Then what do we get? Of course, if we try to simplify the things inside of the square root, we have 1 minus 0, which is 1, all over 2. Now, at this moment, we have 2 problems. First, what is square root of 1? What does that mean? Or in this particular ring, Z6, what would be square root of 1? Or in other words, is there any element after we square that element, it will give us 1? So let's see. 0's square is 0, or 0 times 0 is 0. 1 times 1 is going to give us 1, so this is one of the answers. 2 square is 4, which is not what we want. 3 square is 9, but again, 9 is just 3 in our situation. Then it's also not something that we want. 4 squared is 16, but 16 is 4 mod 6. Again, not what we want. Last, we have 5 squared, which is 25, but again, if we try to divide by 6, we have 4 remainder 1, so it's just equivalent to 1, and this is exactly what we want. Therefore, in this situation, the square root of 1 would just be 1 and 5. So which one should we use? But don't forget, when we say 5, we can also rewrite it as -1. And again, that is because -1 is -6 plus 5, and -6 is clearly a multiple of 6, so they have the same remainder. So in fact, it doesn't really matter which one we choose, because in this case at least, because 1 or -1 will actually give us both positive and -1, plus or minus 1. So let's put it in. We have 1 plus or minus, so again, doesn't matter. We just put a 1 here, divide by 2. Great. So now we end up with 2 cases at least from what we have seen. We have either +1 or -1. So if we have +1, we get 1 plus 1, which is 2, and of course we have divide by 2. Or we have this second case, 1 minus 1, which is 0, divide by 2. Now, here comes the question. What does that mean by divide by 2 here? Is it possible? Well, now we need to go back to the multiplication table again. So let's see. I'm going to do this quickly. Since we're trying to look for divide by 2, we can just try to use the result of the table to help us figure out what we can actually get. So 0 times 2 is 2. 1 times 2, 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6, but that's just same as 0. 4 times 2 is 8, but we'll reduce it to 2. 5 times 2 is 10, and again, if we reduce it, we'll get 4. So what does that mean? If we look at the first case, we have 2 divided by 2. Then we actually end up with 2 cases, because we have 1 times 2 is 2, but we also have 4 times 2 is 2. So in fact, the first fraction, 2 over 2, will give us 2 different results, 1 and 4. Similarly, if we look at the second fraction and use the table, we will end up with 0 and 3. So in fact, we actually get 4 answers for this polynomial, or this quadratic expression. So last, are these 4 solutions all valid? Well, there's only one way you can do. Just plug it in and check. So if x is equal to 1, we get 1 squared, which is 1, minus 1, which is 0. So this satisfies. How about 4? 4 squared is 16, but again, we'll reduce it down to 4, minus 4, which will also give us 0. Good. 0 squared is of course 0, minus 0 is 0. Last, we have 3 squared minus 3. But 3 squared is 9, but 9 is just 3 in this case. Minus 3 is 0. All right, good. So it means that all these 4 answers are actually valid solutions for our equation, x squared minus x equals 0. First, what does this tell us? It tells us one thing. The concept that a degree 2 polynomial here, or a quadratic equation, can have at most 2 solutions, is no longer valid, because in our situation, we actually end up with more than 2. We in fact have 4 solutions. So now let's move on to the next one and see if we'll always get 4 solutions as what we notice. So for a second one, we have our leading coefficients is equal to 1. And then we have b is -5, c is -2. So if we use the quadratic equation, we'll get -b, which gives us 5, plus or minus the square root of -5 squared is 25, minus 4 times a, which is 4, times b, which is -8, so we get +8 here. And then we're going to divide by 2a, but a is 1, so we're going to divide by 2. So let's try to reduce it. So we have 5 plus square root of 25 plus 8 is 33, but 33 divided by 12 is going to give us 2, and we have remainder 9 here. So we will just reduce it down to 9 here. So again, now we need to figure out what is the square root of 9 in this situation. So one thing that we know is, of course, 9 is 3 squared, but we can also write it as -3 squared. Is there any other possible elements here? Actually, no. We can see that 0 squared is 0, 1 squared is 1, 2 squared is 4, and then 4 squared is 16, but we'll actually reduce it to 4. 5 squared is 25, but again, if we reduce it, it will just be 1. And then after that, the rest can be rewrite as negative version of the first half of it, so there is no possible elements other than these two. So again, which one should we pick? Doesn't matter, because no matter we choose a positive or negative, we will still yield to 2 different answers, both plus and minus. So we get 5 plus or minus 3 over 2 here. Then again, 2 situations. The first case, if we choose addition, we end up with 8 over 2. Second one, if we do it, it will end up with 5 minus 3 is 2 over 2 here. So what do we get? First, of course, if we do regular division, 8 over 2, or 8 divided by 2 is 4. That will give us the first answer. And then now if we consider this ring, which is Z12, then another way of thinking it is we can just add half of this number. And again, that's because when we consider half of this number here, which is 6, 6 times 2 will give us 12, but again, that's just going to give us 0. So we can add 6 so that the results will not change. So in this case, we have 4 plus 6, which is 10, and we can double check. 10 times 2 is 20, and then divide by 12 will be 1 remainder 8, which satisfies the numerator part. Similarly, the second fraction is going to give us 2 answers, 1 and 7. But again, are all of them valid? Let's see. So, first one, let's try to write, before we move on, let's try to write it in order. We can have 1, 4, 7, and 10. So let's check each one. First, we have x equals 1. So we will get 1 squared, which is 1, minus 5 times 1, which is 5, minus 2. And that is going to give us 1 minus 5, which is -4, minus 2 is -6. And again, we're in mod 12, so we can add 12 to get the element, to get something that's an element. So we end up with positive 6, but that is definitely not 0. What does that mean? It means that 1 is in fact not a valid answer. Then if we try the second one, 4, we have 4 squared, which is 16, but if we reduce it, it will just be 4, minus 5 times 4, which is 20. Again, 20 is 8, is equivalent to 8 mod 12. And then we have minus 2, and what does that give us? We have 4 minus 8, which is -4, minus 2, which is -6. And again, that means that 4 is also not a correct answer. How about 7? Well, let's see. 7 squared is 49, but that's just 1 mod 12 minus 5 times 7, which is 35. And 35 divided by 12 is 2 with remainder 11. So we'll subtract 11, and then we have minus 2 again. That's going to give us 1 minus 11, which is negative 10. Minus 2 is negative 12, but again, negative 12 will be equal to 0 in mod 12. So 7 is actually a correct answer. Last, we have 10, and I'll leave it for you guys to check, but 10 is also a correct answer. What does that mean? It means that when we don't have a field here, or if the number that we have is not a prime, we could actually end up with a mess, because the idea of degree 2 polynomial will have at most 2 solutions is no longer valid. We can actually end up with 4, but we can also just end up with 2 as usual. And in fact, we could actually end up with more than 4 as well. It really depends how the problems has set up. So, but does that mean we have to actually use the old way of trying all the numbers and to find out the answers? No, we don't actually have to. In fact, we can still use our quadratic formula to give us the answers. But keep in mind, if we try to use that, we might actually find out more than valid answers. We can actually have something that are not the correct answers. Just like when we are trying to solve an equation with square root in the expressions, or something that when we try to extend to the complex plane, we might actually get what's so-called the extraneous solutions. So in that case, once we solve and get to all the possible solutions, we still need to double check and make sure that we actually get only the valid answers, but not including something that are that does not satisfy the initial conditions. All right, that's it. Thank you for watching. See you guys next time.